I'm live now. Can anyone confirm if audio, video, etc. looks fine to them? Since let's just say everything that could go wrong went wrong just before the start of the stream. And sorry for delaying a lot here, but let's get started. So I have also published my ideas like on how I have tried solving these problems. And you can read through this on my Codeforces blog. And like these would also be the ideas that I would be discussing. Is there an echo? Hello? Hello, hello. Okay, let me check once more. One more problem we have for today. Hello, hello. Mic testing. 1, 2, 3, 1, 2, 3. So is it okay now? Hello. Everything is fine. So thanks everyone in the chat. Like people in the chat, like how many problems were you guys able to solve today? Okay, thanks for the audio. Like people in the chat, like how many problems were you able to solve? This will give me fair set of idea on how what are the problems where I should be focusing more and what I can possibly leave. Okay, 6, 2, 5, 4, 3, 4, 3, 4, 3. So yeah, looks like 3, 4, 5, 6 were the place where most of the audience today is. So, and I think we are already quite late, so I will be directly jump onto the problems now. Huh. Like for CF rating, you can look at clist.by. You can find rating over here, like once the contest to be fully passed. So first problem is Koshary. Yusuf is at coordinate 0, 0 and wants to reach a plane of Koshary at x, y. To get there, Yusuf take long steps from any point a, b. A long step moves is to a plus 2, b or a, b plus 2. However, Yusuf is allowed to take at most one short step during the entire journey. A short step moves him to a plus 1, b or a, b plus 1. Can Yusuf reach the exact coordinate x, y of the Koshary plane? So what we have been saying is like we have some starting coordinate. Either we can jump right for a distance of 2 or jump above for a distance of 2. And only once we can jump right with the distance of 1 or jump above with the distance of 2. And the problem asks us to find like the number of, if we can go to the required direction point x, y using at max one short step. So let's see like how does jumping. So let's look at how does the jumps happen. So you are here. You are here. You can jump 2 times. That's what solve this problem only for the coordinate plane, where we have to only move on a number line. Then what you can do is you can try to jump 2 steps. 2 steps. Let's say we want to reach at 8. Then 2 steps more and then 2 steps more. So if the number is even, we don't really need any sort step. We can always do a jump of 2 and we can reach there. But let's say if we have to reach 11, then if we do a jump of 2 more, we will reach at 10. Now if we do a jump of 2, we will reach at 12. And if we try to come back, we will reach at 10. There is no way we can reach 11 by only making jumps of 2. So we will need one short jump of step 1. Essentially, if n is even, no short jumps are required. If n is odd, then we can reach there with what we need short jump, and we can reach there with just one short jump too. Reach n with one short jump. So this is where we are. And now when we have to solve it for 2-dimensional plane, where we have to travel some distance x and then some distance y, then we can build upon the previous idea again. If x is odd, then we need one short jump in the right side, and if y is odd, then we need one short jump in the vertical direction. And only when both x and y are odd, we need 2 jumps, otherwise we need 0 or 1 jumps. We need one horizontal short jump and one vertical jump. And otherwise, like, we can always reach it in at max 1 step, and that's actually the solution we have. The solution looks more or like this. We count how many short jumps we need. If x is odd, then we need to do one horizontal jump. And if y is odd, we need to do one more. And if total jumps are less than 2, we print yes, otherwise we print no. Any questions, anyone on the first problem? Like, checking divisible by 2 is same as looking at odd and even only. So like divisible by 2 equal to 0. Yeah. Yeah, like there are different ways to implement it. If x is even or y is even, then also it looks the same thing. So that's another way to look at this problem. So this is where we are. Any questions, anyone on problem A? Then we will jump on to problem B. So let's look at problem B. It says party monsters. You are given a sequence of length and consists of only characters opening bracket and closing bracket. You are allowed to perform the following operation at most once. Choose a substring. So we need to choose some sequence of some substring of it. Remove it, and then we can insert the removed character back into the remaining string one by one. And we can choose whatever position we want to put those characters in. And Yusuf wants to determine whether it is possible to obtain a regular bracket sequence after performing the operation at most once. And then few jargons of substrings is given to you, regular bracket sequence, etc. is given to you. Let's see what does the problem statement says. First, it says we are given a string of opening brackets and closing brackets. That looks something. Then it says we can choose some set of characters. Remove it from the string. And then we can put these characters back at any place we want. For example, we can put this character here. We can put this character here. We can put this character here. And it says after putting these characters like this, can we get a regular bracket sequence? Like it's our choice which substring we want to choose, how we want to place numbers. And the ask is, can we get the required bracket sequence? And what is regular bracket sequence? Like essentially, like, can we place the regular bracket sequence? Regular bracket sequence simply means the, like, we should be able to place, like we should be able to place 1 and plus signs between the sequence so that there is a valid expression over here. Or another way to put at it is, like every opening bracket should be paired with one closing bracket, and opening bracket should come before closing bracket. Similarly, it goes for the closing bracket as well. So for example, this is a valid sequence. This is also a valid sequence, but this is not a valid sequence, because you see, like, you can match this with this, you can match this with this remains unmatched. Similarly, this is also not a valid sequence. You can match these pairs, you can match these pairs, this remains unmatched because there is no opening bracket before it that we can match to. This can be matched, so this is also an invalid sequence. Similarly, this sequence is also not valid, because technically you say, like, you can argue that I can match these two pairs, but what we need is opening bracket should be before closing bracket, which is not the case here. So in this case, we can only match these two pairs, and that's all. So any question, anyone, on what is the bracket sequence? Now to solve this problem, like what is the simplest bracket sequence you can get? Bracket sequence. Like notice that we needed opening brackets before the closing bracket, right? Because for every valid pair, opening bracket should be before the closing bracket. So what we can do is we can, because what first, let's ignore the constant, the requirement that we should choose substring. We can choose the complete string altogether. Why choose just this part and try to put it somewhere? We can also take the complete string altogether. And if we don't want to change the location of these four positions, we can put it like this. First this, then wherever you want to put it, then like this. So it doesn't really make sense to choose some part of the string. Rather, we should choose the complete string. And once we have chosen the complete string, the most simplest string would be like put all the opening brackets in starting and all the closing brackets after on. And once we create a string like this, we need to check if every opening bracket matches with the every closing bracket and there are no unpaired numbers. And when can that happen? When number of opening brackets are equal to number of closing brackets. And this is actually our solution over here. If the original string contains number of opening bracket equal to number of closing bracket, then we will be able to create a regular bracket sequence. But if they are not equal, then we won't be able to create it. And how we create it? We take the complete string, we keep all the opening bracket in starting, all the closing bracket in the ending, and check if that's a sequence or not. So this was the idea for problem B. Any questions, anyone? Okay, another ideas. Can't we check the size like odd sizes fault, even sizes true? Like that's definitely not true. Like what you if you have three closing bracket and one opening bracket. Like you have one opening bracket and three closing bracket. How will you pair each bracket with everyone? N equal to even and absolute left minus absolute right less than equal to 1. That will actually work. Because if you are saying left is the number of opening bracket and right is number of closing bracket, then if n is odd, then left and right either both of them would be odd or both of them would be even. So the difference will always be an even number. So you will end up with the length left equal to right always. You cannot have length even and difference from left and right equal to 1. And if left and right are equal, then that's what we have been concluding. Like we don't even need to even check for even. Yeah, like the answer is simply like number of opening bracket is equal to number of closing bracket, print true, otherwise print false. So like jumping onto the code for this one, let's count the opening bracket and closing brackets. Open equal to close. Print yes, otherwise print. Any questions, anyone on this one? Otherwise, we will move on to problem C. Problem C is a bit tricky problem. Like people in the chat, like any ideas on how to solve problem C or what solutions you were trying upon? Yeah, 6, 2, 3. Yeah, like mostly everyone has the same idea. In C, make sure that the factors of 2 and 3 are far apart, nothing else. Like you need to also care about the factor numbers that are multiples of both 2 and 3. They can play something, and otherwise we are mostly like multiples of 6, 2, and 3. That's one way to do it. Like essentially multiples of 2, 6, nothing, and 3. Like a lot of permutations will work over there. Yeah, essentially, actually, we need 6 in the ending or the starting. So it says Yusuf has been given an array of positive integers. That f of a denotes number of subarrays of a whose product is divisible by 6. More formally, for every pair of indexes L and R, let's consider the subarray AL to AR. This subarray is counted if product of elements is divisible by 6. For example, 162, then subarray whose product is divisible by 6 are 6, 16, 62, 162. So the count is 4. Our task is to reorder the elements of array so that number of f of a is minimized. So we need to minimize the number of elements that are multiples of 6. If there are multiple ways to do it, you may output any of them. So this is where we are. Essentially, we are given an array. We need to first look at the subarrays. For example, if we have chosen this, then we have to multiply all of the numbers. A3 multiplied by A4 multiplied by A5. We will get some number after we multiply. Let's say if we choose subarray means we have to choose some continuous set of numbers from the original array. So the problem first is we are given an array of numbers. We have to first choose some set of numbers that are continuous in the original array. And then we have to multiply all the numbers in that array. And then check if it's multiple, if this number is this product is divisible by 6. if this product is multiple of 6. And then it says, now we have to look at all the possible subarrays and count how many of them are multiples of 6. How many of them, how many products are multiple of 6? Let's take an example. Like let's say our array looks like this: 6, 1, 2, 9. Now we need to first look at all the possible continuous segments here. You can choose just 6. You can choose 6 and 1. You can choose 6, 1, 2. You can choose 6, 1, 2, 9. You can just choose 1. You can choose 1, 2. You can choose 1, 2, 9. Or we can choose only 2. Or we can choose 2 and 9. Or we can choose 9. These are the possible segments you can choose by taking some continuous part of the original array. Now let's multiply all the numbers in all the given segments. Here the product is 6. Here the product is 6. Here the product is 12. Here the product is 108. Here the product is 1, 2, 18, 2, 18. So what this is what problem is asking us to first look at all the continuous segments, find product of all of these numbers, and then count how many of them are multiples of 6. This is a multiple of 6. This is a multiple of 6. This is multiple of 6. This is multiple of 6. This is not the multiple of 6, like you cannot divide 1 divided by 6. This is also not the multiple of 6, but this is a multiple of 6. 2 is not a multiple of 6. 18 is a multiple of 6, and 9 is not the multiple of 6. And now we have to see how many were the multiples of 6. In this case, the total count is 1, 2, 3, 4, 5, 6. So the answer is 6. Any questions, anyone on the problem statement? So now how do we solve this problem? If you look at the prime factorization of 6, 6 is equal to 2 multiplied by 3. So if a number is multiple of both 2 and 3, then it would also be a multiple of 6. And 3, then it will also be a multiple of 6. And like this holds other way around as well. Like every multiple of 6 will also be a multiple of 2. And if you look at the LCM of 2 and 6, that is also 6. So yeah, whenever everything of multiple comes up, you need to look at the prime factorization of that number. So now overall we can divide every number into 4 cases. Every number belongs to one of the 4 cases. But not by 3. Multiple of 2 but not for 3. Like first case is neither multiple of 2 nor multiple of 3. Of 2 nor multiple of 3. Second question is multiple of 2 but not of 3. Third case is not a multiple of 3, not a multiple of 2, but multiple of 3. Multiple of both 2 and 3. Like this is the overall possible cases you can see based on 2 and 3. Like if you have 2, then the only choice is it's a multiple of 2 or not a multiple of 2. If you have 3, then it's a multiple of 3 or not a multiple of 3. So if you look at both of them together, you will have 4 cases. Number is not a multiple of both 2 and 3, multiple of 2 but not of 3, not a multiple of 2 but multiple of 3, or multiple of both 2 and 3. Any questions, anyone? Like overall, every number can be put into one of these 4 categories. So now the next part. Now like these are the most helpful numbers because they don't do anything when it comes to the multiples of 3. Because you want to decrease the subarrays that are multiples of 6, then like these are the best number which are not the multiple of 2 and 3. And these are the worst numbers for us. If they are the part of that array, then that array would be product of that array would be a multiple of 6. Doesn't really matter for the other 2 cases. And for these two, what you need is, if you have a number that's not multiple of 2 but a 3, then you would also need another number that's a multiple of 3 or not a 2. So for us, like the prioritization and like these are kind of equal only. We don't have a high preference between these two, but these are the worst number for us because every time we have this number that increases any subarray it's a part of, it will keep on increasing it. And these are pretty better number for us. So now let's try to put the numbers of these 4 categories in a given array. So let's first try to see how we can put a multiple of 2 and 3 in the array. Because wherever we put it, it will end up being a multiple of 6. So if we try to compare numbers like this, let's say this is our array. If we put this 6 here, then any subarray that starts from these numbers and end on these number would be a multiple of 6. So for example, this subarray would be a multiple of 6. This subarray would also be a multiple of 6. This subarray would also be a multiple of 6. And overall, you can see that you have 4 choices for the starting index 1, 2, 3, 4, and 4 choices for the 18 index. So due to this 6, we will have 16 subarrays that are multiple of 6. And let's try to put this 6 somewhere else. If we put this 6 here, then any subarray that starts with these elements and ends with one of these would be a multiple of 6. For example, this would be a multiple of 6. This would also be a multiple of 6. This would also be a multiple of 6. And overall, you will have 2 starting indexes. And 1, 1, 2, 3, 4, 5, 6. 6 ending indexes, and which would be total 12 arrays. And you can see as you move from 6 from between to one of the corners, the number of subarrays are even actually decreasing. And in the worst case, if you put 6 here, then what is the number of intervals that this 6 can be the part of? This is the only starting index you have to choose to make it the part of the array, and the remaining element can be anything. So this is one such array. This is one such array, and so on. Total only 1, 2, 3, 5, 6. Only 7 elements. So this gives us an idea that for numbers that are multiple of 6, we should push them to one of the corners. We either put everything in the starting or put everything in the end. Because if you have anything additional here, then you became 2 choices over here and more choices over here. Essentially, if you look at any 6, wherever 6 is the part of, if you have some x choices indexes here and including y choices the indexes here, then this 6 becomes the part of number of elements you can choose from left side minus the number of elements closing index you can choose from right side. And you also have x plus y equal to n. So the most, and you can use AMGM equality or try to look at the graph of this and everything. You will notice that the best minimum possible value you can get is when x equal to 1. So essentially keep x at one of the corners. So this gives us an idea, like we should rearrange numbers in such a way that all the multiples of 6 are in the starting position. 6, 12, whatever way we want. And then we should arrange the remaining numbers. So this is the step 1 over here. Now we are left with multiples of 2, multiples of 3 and multiples of none. And only when we get a multiple of 2 and a multiple of 3, we would get a multiple of 6. And now you can try to place both of these in the original array and try to look at the number of different. For example, if you put 2 here and 3 here, can I not put them in one corner or only at one end? I believe putting it in both the corners should also work. Like I didn't really check a lot on them, but yeah. Or you can probably put it, so like if you put at this, then you can see your starting index should be one of these elements and your ending index should be one of these elements. Then only you can have an array that contains both 2 and 3. Or if you have 2 here, 3 here, then your choice of starting number also decreases, your choice of ending number also decreases. So the total number of subarrays you have where you have multiple of 2 and 3, that will also eventually decrease. So in an ideal world, the best way to put a multiple of 2 and 3 is put 2 in the starting and 3 in the ending. Or you can choose 3 in the starting and 2 in the ending, something. So that only when you choose the complete array, you will get a number that's a multiple of 2 and 3. Keep them as far as possible, 2 on one end and 3 on the other end. So, like when you look at this, like this is how you will end up observing this idea. And when you look at it, like the optimal way to put numbers would be like put multiples of 2 first, and put multiples of none, and then multiples of 3. So like this is how we come up with the idea that we should put all the multiples of 2 on one end and all the multiples of 3 on the other end and all the remaining numbers in between. So overall this gives us the solution like this. Put multiples of 6 first. Come both 2 and 3. Then put multiples of 2. Then put multiples of none. Then put multiples of 3. And this would be our overall solution. Any questions, anyone? Like I will jump onto the code now if there are no questions. So now what we can do is, for keeping the idea simple, we take original arrays input and we can keep multiple of none, multiple of 2, multiple of 3, multiple of 6. Now we go over all the numbers. If it's a multiple of 6, we put it in the multiple of 6. Else if it's a multiple of 2, then we put in the multiple of 2. If it's a multiple of 3, then we put it in the multiple of 3. Otherwise we put it in the multiple of 9. So now we have got all the required numbers. So for an optimal answer, we first print all the multiples of 6. Then we put all the multiples of 2. Then we put all the multiples of none. And then we put all the multiples of 3. And this is one way to solve this problem. Any questions, anyone? This was problem C. Any questions? We will jump on to the problem D now. I got the intuition from the first example test case. Like that's possible. Yeah, like I usually prefer based on the sequence of the problem. At least in Due 3, usually A and B has same difficulty, C and D has same difficulty. So you're targeting for C, then you can try both C. Or you can look at the number of aces and try to do based on that. So now I will go to problem D now. Yeah, like I do record. I upload sometimes, I don't upload sometimes. Today I will probably upload on my other channel. So you can find my screencast there. I haven't uploaded it yet. What to do after I know the solution? You have to code it and submit it. So the problem says Palindromex. You are given, Yusuf has given you an array of 2 and integers. You are given, Yusuf has given you an array of 2 and integers. Every number from 0 to n minus 1 appears exactly 2 times in the array. Our task is to find a subarray AL to AR that is a palindrome, such that max of AL to AR is maximum possible. Output this maximum possible value. So for example, palindrome of string is given. It says that read both backward and same as backward and forward. CAD, A, ABA, C, A are palindromes, but Codeforces or reality AB are not. And maximum is the of an array. Max stands for minimum excludant of an array is defined as smallest non-negative integer that does not appear in the array. For example, max of 2 to 1 is 0 because 0 is not in the array. Max of 3, 1, 0, 1 is 2 because 0 and 1 are there, but 2 is not there. 0, 3, 1, 2 is 4 because all the numbers from 0 to 3 are in the array, but 4 is not. 5 is also not there, but we usually care about the smallest number. So that matters. So this is where we are. We have an integer n and 2 and integers, and every number appears 2 times. So like couple of jargons here. Like one of the question was how to check palindroming subarrays. Like is the question that given a subarray, how do you check if it's a palindrome or not? Or the question is how do we check it for everything? Okay, my stream for this contest, I will upload it on my other channel after the stream ends. You can check it there. So like if you have been given an array, the best way we can check if it's a palindrome or not is we keep 2 pointers. One pointer here, one pointer here. And if both of them are equal, then you move ahead. You move your pointer a bit further here from this side here. And you again check if both of these are same or not. If they are same, then you move your pointer a bit more further here, here. And again check if both of these numbers are equal or not. If they are equal, then you move your pointer a bit further here as well, here and here. You can check if these two numbers are same or not. And if everything was same, always you say it's a palindrome. Otherwise, you say it's not a palindrome because you have found a mismatch. This is how you also check it in the string as well. You have 2 pointers. You check if they are equal, move one step further, 1, 1, 1. And if you both the pointers reach at the same place, then you got a palindrome. So like we have to do it for all the subarrays. Like that's where few observations will come handy. Like for example, what happens if our array looks like this? And someone simply chose this. then the smallest number that is not present in the array is 0 here. So what I am claiming is, if we choose a subarray that does not contain a 0, then the max would be 0. So that's the trivial answer, and if we have to increase our answer, then we must at least choose 0 in our subarray. If subarray does not contain 0. Forget about palindrome and everything. So if we have to increase max, then we should choose subarray that has 0. Now this is where you should also abuse the fact that it says that every number appears only 2 times in the array. So if we look at our original array, there will be only 2 places where you would have a 0. You cannot have more than this. So what you can play around with this here. Now the choices you have is, you just have this element in the array. Then if you have to make palindrome, then the only way you can make palindrome is that will look something like this. And so on. So this would be the centermost element here if we have choose only this element as the 0. So the idea is, we can choose this 0, and we can, instead of choosing an array and checking by moving left, what we can choose is, we can choose the middlemost element and we can move right as long as the numbers are equal. If we start here, we move pointer here, check if they are same, then move right. Again check if they are same, then again move right. If they are same, then again move right. Now you will possibly find, let's say, 9 here and 7 here. Then you stop. So now this is one array, you should check and try to find the max of it. Yeah, like Manchar is one more advanced algorithm, but that will rarely appear in the problems which are less than 1500 or something. So for the first 6 problems for Div 3, you should try to look for. Then we should only start from minimum element, right? Because that will give us the maximum max. Yeah, like kind of that only, but minimum element is 0 here. So that's why I have simply chosen 0. So you have to keep 0 in your array, otherwise your element is gone away. And if there is only 1 0 in your array, then that must be the element in between. Because if it's not in between, then you will have to get at least 2 0 1 from the first half of the array, 1 from the second half of the array. Similarly, you can choose this as the middlemost element and try to increase pointers from here as well. So these are the 2 cases when you can have 0. And one more case over here is like, your string looks something like that. Such that it contains both of these zeros. So the only way if we have a big string that contains both of these zeros, then the way we can get over here is like, you notice, like if you start from this pointer, because like these are the only two, 0 does not appears more than 2 times. So if you start from this side, at some point of time you will come here and match these two places, and then you will again go few sides left and try to reach a center over here. So what you can do is, in this case, first you start with this. Let me take this 0 separately again. So you are assuming our potential string is something like this. So what, and we know that at some point of time this string should match with this string, this 0, because these are the only two places where you have two zeros. So what you can do is, first you can start from this side and check if this string is a palindrome or not, by going one step at a time. If this string is a palindrome, then similar to the previous case, you start from a pointer here and here, and you try to move right. And this is how the idea would be. If you have only 1 0, then you, instead of moving from other place, you go to that place and you start moving to the right. If you have, you can try it for the other 0 as well. And if you have both of the zeros in your array, then you look at those arrays as one of the endpoints. You check everything in between them is a palindrome, and then you try to increase both of the ends. And that's how you can get the longest string subarray that contains both of these zeros. And these are the three cases you have to actually check, and that's where we are. Any questions, anyone, on the problem statement first? So this was the overall idea. Yes, this is D. Let's try to code it. What I will try to put it this way is, like, I can code just the algorithm for these two zeros and reuse it for all the arrays. My algorithm overall will look like this. I will give the one starting and ending index of a 0. You check everything in between first, and then you try to increase on both of the ends. First, let's try to find the position of 0. Zero left. Let's say our algorithm takes this. What we can first do is, we can make the first position where 0 has both 0 left and right, because each 0 matches up. Or we can make this as a 0 left and right, or we can pair each of them with each other. And we try to run the algorithm for all of this. First, we start with L equal to 0, L equal to 0 left, and R equal to 0 right. And L less than R, L plus plus, R minus 1. If AL is not equal to AR, then we simply return here, because this starting and ending of 0 does not give us a palindrome. And once if the left part is the 0, then we try to extend for the left endpoint. While left is greater than equal to 0 and right is less than equal to n. Left is equal to a right. We increase both left and we increase both. Or let me put it this way. Left minus 1, right plus 1. Left should be greater than 0 and right should be greater than. So now left to right is the maximum palindrome we can get. Now we put all the numbers from left to right in a set. And then we try to find the max of it. If current number is in the set, we increase our count. And we take answer as answer of what are the current answers and the max. This is the overall solution for problem D. Array length is 2 times n. Left minus minus, right plus. This is problem D. Any questions, anyone? Not we will next problem. Yeah, like left plus plus right minus, that was the problem. So this is where we are. Of more minutes and then we will jump on to problem. Let's move on to problem E then. Yusuf has n columns of cubes starting side by side. The ith column contains ai identical cubes stacked vertically. Initially, gravity pulls cubes downwards, so every column contains cube exactly at 1, 2 up to ai. Suddenly, gravity shifts to right and each cube slides horizontally as far as possible. A cube cannot go past or overlap other cubes and it must remain at its original height. Final configuration is uniquely determined by the initial heights. This is actually quite a good hint. Before the gravity shifts, Yusuf may perform at most one operation. Choose an index I and decrease ai by 1. That is, remove 1 from the any column, top of the any column cube. You may choose not to do anything. It's our choice if we don't want to do anything either. Find the maximum possible number of cubes that will move after the gravity shifts. Assuming Yusuf applies the single decrease operation optimally or chooses not to do it. So this is where we are. Problem statement goes like this. It says we have initially have some cubes placed on a plane that looks like. On the top of each other. Let's say these are our cubes. Now it says we have to somehow pull these numbers on the right side. Like we try to align these numbers assuming this was the horizontal. So on. And overall what will happen is this cube will move from here. This cube will move here. It cannot jump all the existing. These three cubes will shift by 1. And nothing will happen on the remaining. And it asks us to find, like, after you have something like this, what is the number of cubes that change their location? In this case, the answer is 1, 2, 3, 4, 5. 5 is the answer. Any questions, anyone, on the problem statement before we jump out to the solution? So, like, now the crucial idea over here is if we focus on this column, that was the original column, nothing has changed over here. Nothing has changed over here too. Nothing changed here too. But here, this guy decided to move to the right. Why did he do that? Like the reason is there was a vacancy over here. Like this place was empty. That's why this guy moved on right side. Similarly, this guy moved to this position because this place was empty. And overall, if you try to notice here, let's add a few more rows here. In this case also, like now if I check it here, this guy will move, this guy will move, and this guy will also move. You all can see we need to maintain, yeah, like that's the idea. Like these three guys will move from here even though there are places, because there was some vacancy in this complete row. Yeah, I am. This is one row. This is one row. This is one row. These three guys moved because there was at least one row where we had a vacancy. In this case, this is where we have a vacancy. So, or another way to put at it is, in this row, only these guys did not change their position. This is problem. And the reason why only these two guys did not change their position was because all of these rows were filled over here. So this gives us an idea. If we are focusing on this row, we should look at the row that has the minimum number of cubes here. In this case, that's 2. So only 2 people will remain here and everything else will move away from here. So here we have 5 guys. Among 5 guys, only 2 will remain at the same position. So total 3 of them will change their position. And this is actually the solution here. We have this array A0, A1, A2, AI. We should look at the minimum of this and check the number of guys here. Those would be the guys that will still remain here and everyone else will change over there. So the number of people that change their position would be AI minus that minimum you get. And this actually ends up being the solution. This is problem E. And I am not yet figured out like how to find, like I am right now just solving for the case when we don't have any guys. We don't do any operations. What we can do is we can maintain one in, we go from right to left. We change our minimum with the current element. And then the number of people that will change their position would be equal to AI minus number of people who did not change their position. So this is the first part of this problem. Now we have to also handle the case when we remove one of the guys from here and try to somehow increase the opacity. Again, the idea would be similar to minimum. Let's say, now I won't draw cubes now, but let's say we have 7 cubes here, we have 5 cubes here, we have 3 cubes here, we have 6 cubes here, we have 4 cubes here, we have 2 cubes here, we have 5 cubes here, and we have 3 cubes here. Now, because of this 7, like 7 elements will remain at its position because 7 is the minimum to the right. For this also, 5 people will remain at the same position. For this 3 also, like since 3 is the minimum of everything, 3 people will remain at the same position. Here also 3 people will remain at the same position because of this guy. Here also among the 4 people, 3 will still remain at the same position. Here 2 people will remain at the same position. Here 2 people will remain at the same position. And here also 2 people will remain at the same position. Now what happens if I remove one guy from here? So I make it 2. So then in that case 2 people will remain here. Only 2 people will remain here. Only 2 people will remain here. So you will remove one guy from here and these 2 guys will also shift their position to the right. So 3 was the minimum at 3 indexes and you ended up increasing the number of movements by 2. Similarly, if you change this guy to 1, you will simply remove this coin altogether and the people who are at 2 and 2 will move one step to the right. So again gives you a 2. So essentially what you need is you need to know the minimum for each row and just pick the value that is minimum most of the times. So you remove that from one place and everything will shift to the right. Because our solution was AI minus minimum, right? So if we decrease this by 1, overall value increases by 1. We need to handle for the case that where we have removed one coin simply from the complete array. So what we need is the count of minimum for each value. How many times this element has been the minimum? Next move would be like these would be the number of rows where this is minimum. Because we will remove that guy, there would be one row where the elements itself will decrease. So we will end up moving how many times this element is the minimum, minus 1 as the number of times this guy will move. Overall, this would be our solution. Any questions, anyone? The idea is your answer was dependent upon the minimum of the suffix. So the guy that appears most of the time as suffix would be the guy that will increase your equation, because your equation is AI minus the number of people that will remain same. If you increase minima by at one place, then the complete suffix minimum will also change. Any questions, anyone? Okay, can I explain the delete operation? Sure. So my overall idea was like this, right? We had a guy with that has 3 elements here, a guy that has 4 elements here, a guy that has 4 elements, a guy that has 2 elements, That is 6 element here and so on. Initially, when you were moving things around, these 3 elements remain over here. The 1 from the top and 2 from here move. Now, if I remove one guy from here to make it 2, and both of these guys will start moving to the right. That's where, like, you keep what are the minimum you have seen for each of the rows? 6, 3, 3, and so on. So when you remove one guy from here, total elements here become 2 and 2. The element where this was the minimum, both of these shift by 1 1 each. Total 2 rows or operation count has decreased by. So that's how our delete operation is. So this was problem E. Any questions, anyone else? Like this will actually create a chain effect. That's why 2 rows have shifted here. Now you have only 2 guys here. So nothing will happen here and anything before it. Because even if you have 5 guys here, anything above 2 would have already been counted because these guys would have moved earlier too. Like these guys will move regardless of whether we remove something from here or not. So the only continuous part is what one slide row will shift from here. So whenever you, because you have everything shifted, like let's look at it like this. You have the original final array with you that looks like this. And everything is already shifted here. Like let's say this was our sequence without doing any operation. Now if you sneakingly remove a guy from here, then only this part will shift here. Or if you remove someone from here, then this complete part would move to the right. Etc. looks okay. Etc. looks okay. Like my battery died. So percent battery. It was buffering for everyone, but is it still okay now or is it still bad? Yeah, like essentially my battery died, so that's where we are. Okay, thank you. So the sim actually remained connected. So any questions, anyone on problem E before we jump on to problem D? So rating of E, I will probably rate it around 1500, 1600. Probably. Like actually, I am not a lot aware between the rating of 1000 to 1800 or something. Everything mostly looks a bit faster to me only. So this is where we are. Otherwise, let's move on to problem F. Like at this point, I would say I won't rely a lot on the number of stalls here. Like, because these numbers many a times looks a lot inflated. I will definitely rate this to be solved in due 3 not more than 200 folks, but you have 450 or so here. And you can probably guess why we have an inflated count. So now we have the same setup for problem F as well. The only difference is now we have to take the sum of the distances every node has traveled. So in this case, if you see this guy has traveled by a distance of 3, 1, 2, 3. This guy has traveled by a distance of 2. This guy has traveled distance of 1, and this will also travel distance of 1. And we have to find the maximum possible distance and maximum possible distance if when we remove one of the nodes. So this is where we are. Any ideas, anyone on this problem? So like now here we have to look a bit differently because we have to find the distance traveled. What we can possibly do is, again, not a pre-computation. Like the idea here would be like this. Let's again draw some diagrams here. Instead of counting for each node how much they have traveled, let's try to count at this junction how many people have crossed from this side to this side. That cross each. So like essentially what I'm saying, if this is node I, this is I plus 1, I am calling this as a junction in between. And I am trying to find out how many people will go from here to this side. Because like if a guy has to travel, like let's say 3 times, then he will end up crossing 3 junctions here. The screen has not changed. I think screen did change, right? Right now, like I am on whiteboard. Everything is. So like rather than counting for each node how much they are traveling, what I will do is I will go ahead at each junction. Okay, yeah, you are right. Like I have a whiteboard, but that whiteboard location is not changing. Yeah, right. So yeah, like starting again. I have first drawn the diagram again. What I am saying is, like rather than counting how much each person goes, I first define something known as a junction. For example, for this node between I and I plus 1, I call this as a junction, and I am trying to find how many people will cross from this side to this side. Count number of people that cross each of the junction. So for example, if a node travels distance 3, then he will end up crossing 3 junctions, right? So what I am trying to do is, instead of counting for each node how much they are traveling, I will count how much nodes cross this particular junction How many people cross this junction? 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 And if I take the sum for all of these junctions, then that would be the total distance traveled. Sum of people crossing each junction is equal to total distance. Like at times, like this is quite a helpful idea. If someone says count x, instead of counting x, you count y, and then you try to prove that both of those counts would be equal. So if I can somehow count for each junction how many people are going to cross it, then I can also get the total number of people who have crossed it. And how do I find how many people have crossed it? Like let's say if my original junction looks like this. Let's just try to find the terminal state. Terminal state would look something like this. Then if I have to count the number of people who have crossed this junction, what I need is total number of people originally in this part minus the total number of people who have still remained in this part. Is equal to number of people before initially minus count of people that remain. So this is the idea over here. And like now the important part is how do you find the count of people on each node after you slide it. If I can somehow find the number of people in each of the row that will remain, then I can simply look at for each junction how many people were there in the starting and how many people that have remained, and the difference of them would be the people who have crossed this boundary to go right side. Any questions, anyone so far? And the idea is like the final order is simply the sorted array. Okay. No questions, right? Or do you have questions? We can find final order by sorting the array. The key idea is we know that the final order would always be sorted because otherwise the element will jump over here. Like if you have elements like this, then these folks will jump from here to here. So if you have like let's say 5 elements here and 2 elements here, so after the wind comes in, 3 folks will move from here to here and you will end up with 5 folks here and 2 folks here. So the heights will actually never change. It's just that you can kind of see it like this, swapping 5 and 2. So, or another way to look at it is pick up the smallest guy and try to move it early also. Like essentially what I am claiming is final order is just the sorted order array. And you can try to visualize it because whatever vacancy anyone has, like they will end up only moving those people earlier. So this way I can find how many people have crossed the boundary for each of the nodes. This is the count if I don't do anything here. Now we again have to remove one guy from the set and somehow do something. Like the idea would again be same. Okay. Like let's say we have changed some guy, like the original array was like this 5, 3, 4, and our sorted array became like this 3, 4. Let's make it 4, 3, 4, 5. Now if you remove one guy from here, if you make this from 3 to 2, you can figure out which element in the array would become from 3 to 2. And you can take the difference of this distance as the number of, so like there would be, you will have a, you kind of, if you look at it, if you are on this side, nothing changes. For everything over here, for each of these junctions, you have one extra people who would be moving to this side, and here again nothing happens. Like you were looking at, another way to look at is you were looking at sum of A and sum of B. When this guy changed from 3 to 2, the sum decreased by -1. This sum remained decreased by -1 until you removed one more guy from here when the sum balanced. Like if you remove one guy, one cube, then your some part of the array, your sum of A will decrease, and some part of the array, your sum B will decrease. And only when none of, at one of them decreased and one didn't, would be the area where you will have an increase in the count here. So this guy will also decrease by 1, this guy will also decrease by 1. So, and you care about difference. So for some part your sum will decrease and some part your sum will not decrease. So this is where we are. Now we need to find, like for every node, what would be the new index they can go to. New index where they can go to. If new index in the array, then you take new index v equal to minimum of new index v comma I. Else you set new index v equal to. So you have found for each element, if you decrease it, at what position it will go to. Because the idea is, for example, if your array is like this, 1, 2, 2, and if you would have changed 1, 3 from 2, then the first time 3 appears here, this would have become 2 and the remaining sorted array will remain same. Or for example, if you change 4 to 3, then the first time where 4 has appeared would have changed. Or if you change some 2 to 1, then your sorted array would become 1, 1, 2. So what you need is the first index of that 2, because that would be the new index where your sum b will start decreasing. Maximum of move. So your distance becomes, let me check if it's minus I or I. This would be I minus. Wait, what? Okay, this should be sum a minus sum b. So the number of elements should initially be higher and some part will move. What? Okay, so I have to also add move. Huh. I actually don't remember what was the condition here, so I will just go ahead and look at my submission. This should be I minus. What is the current location and how much earlier it has moved to? This is problem F. Any questions, anyone? First we'll move to G and H and then wrap up today's stream. Actually quite long, but so I will try to wrap up G and H quite a bit faster because it's already around 2 hours since the contest. And yeah, like this is actually a green screen and my OBS filter is not really good. So you see kind of things. For example, if you see something below my hand or something. So there is a green screen, but it's not doing a great job. Wait, I ended up removing monitor. Okay, we should be back now. So I was just looking at why my green screen is not working. Ended up messing with something. Hello. So that's where we are. I believe my screen and everything is better now. Like a lot of experimentation has happened today. So let's move to problem G. It says Yusuf has an array A of n positive integers. He defines a reduction operation on array C of length C where length is greater than or equal to 2. Choose an index I such that the sum of elements before and after it is more than the current element. And then I remove these three elements and replace it with sum of elements minus my current element. And we say an array is good if we can make it just one element by performing some number of operations. Note that the length array of length 1 is always good. Now we have to count the number of pairs L and R such that the subarray AL to R is good. So, like, this is the problem G. I will possibly wrap it a bit faster. So, overall, what it says is, let's say we have this as an array. Let's take one of the sum. Let's say we have this. And in this, we can apply an operation where we choose three elements. And if sum of first and the last element is more than the next element. And the operation is as follows. We remove these three elements and replace it with sum of first element, last element minus the middlemost element, which becomes 80. So our new array becomes 30, 80 and 7. Now we can again apply an operation because 30 plus 70 is 100, which is more than 80. So I can again remove these three guys and replace them with the difference of these two, which would be 20. So my final element becomes 20. So in this case, I was able to reduce this element to just one element. Now the question is we have to count it for all the sub arrays and count whether we can reduce it to one element or not. Before we try to count, like let's try to observe when we can make an element equal to 1. Notice that every time we are decreasing two elements, so my starting length should be odd. Because if I have an even length, at one point of time, my length will become 2 and then I cannot make it 0. And then we have some more conditions possibly. One of my bold claim is, let's first forget about this condition at all. Let's simply forget about this. Let's just forget about this and let's try to do this operation whenever we want. Operation whenever we want. In random order or whatever we want. And make it size 1. One of the most important observation was it doesn't really matter how you do operation. The last element you will get will always be same. Like this is quite a bold assumption, but you can try to play around over here. You can try to formally prove it. Like for example, last time in this array we ended up with 20, right? Where we chose these elements. Let's say we first choose these two elements. This will result in 10. And then we have 10, 60, 70. So 10 plus 70 minus 60. If you apply an operation again here, you will end up with 20. And if you try it a bit more, you will realize this final element is nothing but sum of odd index minus sum of even index. Like you can, like the way you figure out is you take 5 elements, try to perform it and do things over here. For example, if I have to just take arbitrary number a1, a2, a3, a4, a5. If I apply an operation here, I will end up with a1, a2, then a3 plus a5 minus a4. And then you apply an operation over here again, then you will end up with a1 plus a3 plus f minus a4 minus a2, and another way around as well. Like parity ways, you can take assumptions here, and that's the bold claim. So now you notice that whenever I am replacing this element, this new element will also be positive because ci minus 1 plus ci plus 1 is greater than ci. So the array always has positive elements. Because you initially started with positive elements and you do operation only when they result in a positive element. So leaving everything aside, the bare minimum requirement earlier, but the bare minimum requirement I had was all the length should be odd. Now I am saying because every time all the numbers are odd, then the very last number I have should, all the numbers are positive, then the very last number I have should also be positive. Because if it gives you a negative, then there is no way you can possibly do it. Should also be positive. Like this is also a necessary compulsory condition for me if I am able to make an array of size 1. Right now I am not saying ki like we will possibly, it's possible that we may have more conditions over there, but I am saying this should also be true, otherwise there is no way you can make an array of length 1, because the very last operation you do that gives you the final element that should also result in a positive element. This is my condition number 2. And what it turns out is like these two are the only conditions. If I have these two conditions, then I will also be able to make element 1. Like the other way around, it's also so. And final element is sum of at odd minus sum in even. Now what I am saying is like these two I have first proved that the must have conditions for me. Now what I am saying is like if I have these two conditions, then I will always be able to make an array of length 1 as well. And the whole idea is this. What I will do is I will always choose I equal to even index. And if my array is like this, a1, a2, a3, a5, if a1 is greater than a2, then I can simply apply an operation here. Otherwise, we know that a1 is less than equal to a2. Now, if a3 is greater than a4, then I can apply an operation here. Because this also is positive, that will only keep something extra. Otherwise, my a3 is less than equal to a4. Now, if a5 is greater than equal to a6, then I can apply an operation here. Otherwise, my a5 is less than equal to a6. Now, because we knew that sum of odd is greater than sum of even, a1 plus, like this was our condition. So this final number would be too large, and this element is smaller than this. This element is smaller than this. This element is smaller than this. But somehow this overall sum is positive. So it must be the case that this number is very, very large. Then only my overall sum can be positive, because I know that these first three elements are less than this. So in that case also, I would be able to apply an operation here. And I can keep going over here. So this new number would be a7 plus a5 minus a6. And you can see like sum of odd and even numbers still remain same over here. Every time sum of odd and sum of even difference is always the same. That's where we are. So these two are the necessary and sufficient, more than enough conditions for me to check an array of length. Now the problem statement asks us to count the number of subarrays. So what you can do is, you can first change all the even numbers to multiply by. Essentially what I can now do is, usually we maintain a prefix sum. This time I can maintain an alternative sign prefix sum. Which in the sense means a1 minus a2 plus a3 minus a4 plus a5 minus a6 and so on. And overall my condition would become PR minus PL minus 1, which is greater than 0 when R is odd. I will probably not go into a lot of details here. You can look at how prefix sums etc. works and try to get a out over here, like this is actually problem G, and that's how we are. And similarly, you can try to find it for odd index as well. So overall, your condition will remain become like this. Here are some prefix arrays. Now for this index, like let's say pref odd, count how many elements are less than this in the other parity over here, which is this. I am mostly avoiding to going into the details here, and that count you can either use PBDS data structure, which is a standard library in C++, or you can use Fenwick tree with coordinate number. I have actually, this would be the overall idea. Like I haven't gone into a lot of details for this, but I am hoping you would be able to figure it out since this is problem G. So like that would actually be a good homework exercise. Yeah, I need to also count ordered set even. Number of elements less than odd sum, and this would be the overall idea. Similarly, I am also maintaining some even sum for the even counter. And I need to also include ordered set. Hmm. Is that index? Hmm. Really, sir, where I am making a mistake. Idea overall looks for order of the when we are at odd index. I will try to wrap up this. I won't be discussing the last problem. This would actually be the last problem for today. Like somewhere something is wrong and I will actually skip it. Like I have to move. Uh, Wait 1 second. This is 0, fine. So actually I will mostly paste the submission link over here. Some odd even length making some difference over here. And thanks everyone for joining in today. This was my stream. I have to actually jump for something. Thanks everyone for joining today.